2.6 Formulas. A formula is something that I know you've used before, and you've used it in many different ways. It's things that you've seen, and we'll look at all different examples of it in a few moments. But a formula is not something to be too difficult. It's actually something that helps you out. It's a rule made of variables. And a lot of times you memorize formulas because it really helps you. Things like distance equals rate times time. That would be one that you used in jousting armadillos. It's made of variables. It's a rule. It's one that you don't have to memorize because you can figure it out. However, if you do memorize it, it makes life a lot easier on yourself. So what we're going to talk about here is not only using formulas in this unit, but we're also going to be talking about how the variables are related to one another. So it's going to be very similar to the different families that we talked about before. The hyperbola family, the parabolic family, and the linear family. So you'll see that in a moment. But let's remember, what is an independent variable? Well, the independent variable, remember, is always the x-axis or the x variable. And that's the one that it doesn't matter what is happening with y. It is what it is. It's independent. It's on its own. So it's you can choose any value you want. And in this case, the independent variable is time. The dependent variable, however, is the y variable, and that depends on y depends on what x is. So see, d here is dependent on what r and t are. Or if we just ignored r, d is dependent on t, right? D is the dependent variable. T can be whatever it wants. It's going to dictate then what d is. In this case, it's speed. The speed depends on the time. It depends what time you are on this graph to figure out what the speed is. What depends on what? So remember this graph, a car approaches a stop sign. We've got our independent variable, our dependent variable, and our function that's a story. Okay, examples of formulas. Formulas are derived from patterns. So when you see a pattern repeated over and over again, typically you write a rule, and that rule is considered a formula. They're streamlined to be used over and over again. Distance equals rate times time. Here's one you're going to use in this lesson. It's going to feel complicated, but it's actually not so complicated once you get into it. E equals mc squared. This is a very famous formula that you probably have heard before and not really used before. So you get to use it in this lesson. How about this one? Perimeter equals 2 times the length plus 2 times the width. Well, if I gave you a shape, you could probably figure out the perimeter without that formula, couldn't you? As long as you had this the width and the length, you could figure out the rest. But you could also use the formula to make it faster, perhaps. Area equals length times width. Volume equals length times width times height. Circumference equals pi times diameter. Area equals pi times radius squared. And then density equals mass over volume. So these formulas kind of all fall into different categories, which kind of makes the hard part of our lesson. And here it is. So this is the crux of the lesson. The rest was just kind of setting you up. So if you're writing your note to self, this is really the information you're going to need in there. So there's 3 kinds of variation. There's also 3 families that we've discussed, and they're exactly related. We've got direct variation, we've got variation with the square, and we've got indirect variation. Okay, so if I look at this example, E equals mc squared. It feels like there's a square in there, but actually, as you'll learn in this lesson, c is just a constant. C stands for the speed of light, which is really just a number. So c kind of disappears. In fact, I wouldn't even think about it for a moment. So you've got E equals mc squared. So actually, E depends on what m is. Those are my 2 variables. So this is considered direct variation, sometimes called linear variation. What you would say, so I'll put this in quotes, the green is, E varies directly with m. We want to know What happens to E? How does E exist with M? Well, E varies directly with M because whatever M is, that impacts what E is. Okay, here's another example that doesn't have that square in there to kind of throw you off. P and S are my two variables. This is perimeter equals 4 times side. So this would be the perimeter of a square, right? Because if you know the side of the square is 2, wouldn't you just multiply it by 4 to get the perimeter? Yes. So how are P and S related? Well, P and S are my two variables, but my perimeter depends on what my side is, right? So we say P varies directly with S. Means you need to know exactly what S is, and then we'll figure out what P is. Okay, now the next kind, I'll use red, the variation with the square. So now, in this case, we've got K equals 1/2 mv squared. My two variables here are K and V. M is going to be a constant, like slope. We'll have that filled in with a number. But K and V squared are going to be the things that are changing. They will be the variables that we're looking at. So K varies directly, or I shouldn't say that right. K varies with the square of V. K varies with the square of V. This is also known as a parabolic relationship. This was linear, this one's parabolic. K varies with the square of V. Okay, our final one is called indirect variation. This is going off of what the hyperbola was, that family. Sometimes called inverse variation. This one, we're looking at D and V are our two variables. M is going to be filled in with a constant, like a slope or something. So what we would say is that D varies inversely with V. D varies inversely with V. D depends on what V is, and because V is in the denominator, that's how we know it's going to be inverse variation. So D varies inversely with V. So I would pause this video, get this information down, and then try to utilize it in the lesson. It's pretty complex, but you don't have to do so much with it except for really recognize which type of variation it is. So as long as you can put it into one of the categories, you should be pretty good.